Hello, everybody. Good morning. Top Wolf, Uchu, Yang, Kane, CS202 student, Fuzzy, welcome. Happy Tuesday. It's not Monday anymore, right? Yesterday felt pretty Monday-y to me. Yesterday was definitely a Monday. Morning, Chef. Morning, Synthos. Morning, Waffle. We've got a smiley face for Tuesday here in the last session we have before the test on Thursday. Okay? Just reminding you guys. Good morning, Hammo. Welcome. Yeah. Smiley face. Just your average Monday. I saw some funny memes about that Facebook thing yesterday. Good morning, Pig. Welcome. Our class is Tuesday, Thursday, so our test will also be Tuesday, Thursday. So the test is on Thursday. Right? I'm not crazy. It is Tuesday today. I have been forgetting what days of the week it's been, but I think I'm on schedule. Oh, we had a hiccup there, huh? Connection problem? Well, you guys will let me know. All right, let's see here. So, we are starting class now. It is 11:30. All right. Don't you try to tell me today is Saturday. It's not. I know it's not. There are just a few quick things I want to mention. For one, I did upload the review. I uploaded these review documents. I hope you took a look at them. I've been developing those over the last 3 semesters I've taught, so they should be pretty clean. And I thought I got through everything except for the last 3 questions on pointers. So we're going to take a look at those real quick. I know we had a question last class that said, hey, is this the last day we're going to have stuff that's on the test? And I said yes. And I plan to stick to that as much as possible, but I do want to look at these questions. And I just want to go over them. If I do decide they should be on the test, please pay attention. You shouldn't be scared because you're going to have the review sheet anyway. So let's just quickly go over these because they are important. Yeah, it is in the files. You can find it. I don't think anyone hasn't found it. You can let me know, but I do remember uploading them. So one of them is all of the questions, okay? So there's like no answers in this. I guess I have my name up here. That's silly of me. And then the other one is the answers, so you can go find them. And I did explain all of these. Now, unfortunately, I was looking at kind of our schedule, and today I'm not going to have very much time for a review. We'll see how far we get, but chances are we're not going to get to it. I do have review sessions from previous classes, so you can kind of scour my... you can kind of go through my old YouTube videos, and you can find a session where I did do a review. And I used the most recent one, I would have used the same document. So if you do want to watch a video, you're welcome to. But as for right now, we're just going to go over these 3 things. And then we're going to get into just a few more things we need to talk about pointers. So let's go in order here. The first thing we want to talk about is what operations are legal on pointers. Now, I never covered this, but it is important to understand. And I do want you to know this, and I will say that just after reviewing these questions may be on the test. Nothing in terms of code, but I may just ask you that question. What operations are legal on pointers? Now, I know you already know one of them. What's a legal operation on a pointer, do you think? What's a legal operation on a pointer that you know of? We've done it already. We've done some this year already. All right? You guys know this. What do you think? Dereference, yeah. Yeah. All right, you know that one. Dereferencing is great. Equals, yeah. Boolean. I think Boolean is fine. Yeah, I'm going to group... I'll put them all out there. Let's see. You can take the address of a pointer if you want to. I wouldn't recommend it, but that's legal for sure. The deref, I'm gonna group in all three of those things you guys are talking about there. The star, the arrow, and the brackets. All right, but there's one more thing with the brackets. What else does this do? What's the operation that it does? It dereferences it, but what else does it do? Let me kind of ask this question. Any math equations? Any mathematical? We're just going to stick that to mathematical, right? There's an I in there. There's an E. I don't know. You guys can tell me. Any mathematical operations? Okay, minus, I'll take it. Plus, right? So that's what we went over. Is that what do the brackets become, right? If I had my array at I, that becomes a dereferenced version of the array plus I. So you're allowed to add. You're allowed to add two addresses. So that's kind of what I was getting at here. Of course, you can answer these with this, but the most important thing you need to know is that you can only add and subtract from pointers. When it comes to actually mathematical operations, you can add and subtract from pointers. You cannot multiply or divide. So that makes sense, right? Are there any questions about that? So I may ask that on the test, okay? I'm not lying to you. I may do that. You've got the answer right here. Okay? You can only add and subtract. So now we're going to talk about this next thing here. Now, we kind of did it in the code a little bit last time. I just haven't gone over it yet. And we're going to kind of learn it in pieces because there's a lot of stuff involved with this kind of thing we're talking about here. So let me pull this up here. Let's see. So the first question is, what do you consider when using the rule of 3? Okay, what do you consider when using the rule of 3? Now, I haven't gone over this yet, so we're going to talk about it. What do you consider? So here we're going to bring this up, and you must always remember this. So the first question is, let me just repeat it one more time. When, sorry, not what, but when do you consider using the rule of 3? Well, when should I use this rule? Okay, when should I use this rule? Now, Chef, you're partially right. First, let's talk about when we should use this. And whenever we use this is when a class contains a pointer. All right. So we did that last time. That's kind of why we didn't really go over it. We built this class here, and notice that this has a member here. Let me kind of bring this out wide. Let me bring this out wide here so we can really get a good view of this. This class we have declared here, the CS202 string. It contains a pointer inside of it, which means we need to consider the rule of 3. All right, we should use the rule of 3. All right, so that's the answer to that question. All right, when should I use this rule? Whenever a class contains a pointer. That's the answer to that question. So if that's on the test, you can't be mad at me. I just gave you the answer. All right, and today we'll talk about it, of course. I'll give you a little image to show you what's going on here and why we need to do it. And then the last thing is what three things are involved. What three things are involved with the rule of three? Now, Chef got one of them right. I would say probably most importantly is a destructor. All right, a destructor. It's almost that like a destructor is. It's like main purpose in C++ is to deallocate memory. And so it looks like some of you guys have been reviewing. Pig, I'll get to your answer in a second. I think I know what you were answering there. Maybe. But Top Wolf here says the destructor. And then if you looked at the review, you'll see that the second thing that's involved is the copy constructor. And then the last thing that's involved is actually called the assignment operator overload. Now this is coming up later, okay? So I'm never going to ask you to do anything like coding like this on the test. Really, I just want you to answer this question on the test. What three things are involved? I'm not going to make you code any of these things. I just want you to know that it's a requirement to consider these things, all right? So this comes when we get to operator overloading. That's coming up here pretty soon. But now let's talk about why we need to consider these things. And so another part of that question is what memory issues are we aiming to prevent? So this is, I asked this in the comprehension questions for assignment 4. If you guys haven't done that yet, please go take a look. The comprehension questions for assignment 4, and I think Pig there was kind of answering this. What are the three main memory issues that we consider in C++? And that's the memory leak, that's the alias, and that's the dangling pointer. So the reason that we consider a rule of three is actually to prevent some things, some of these memory issues. So if we do not implement a rule of three, memory issues may ensue. I don't know, may happen. I'm using words that are too big for my vocabulary. I don't even think ensue. I can do that, right? Is that, whoa. Whoa. I think it's like that, isn't it? I'm smart. I think so. I think that's right. Where's my mouse? I've got the sensitivity adjustment on my mouse and I messed it up. Alright, we'll go with that for now. So if we do not implement a rule of three, memory issues may ensue. Now mainly, we have the memory leaks. You guys should know the answer to this one. Of these three things, or of these two things that you know of, one's a destructor and one's a copy constructor, which one for sure prevents memory leaks? You know this. And then the other thing that it considers eliminating is alias. It considers eliminating aliases and even dangling pointers. Maybe, but mainly aliases. Yes, thank you. So, the destructor uses the delete, right? Yep. So the memory leaks are helped out here with the destructor. All right. So the destructor handles the memory leaks. Why? Because it's going to return the memory back to the operating system. All right. The memory leak is prevented when the destructor kindly returns that memory to the operating system. Now, the copy constructor in the assignment operator overload aim to prevent alias, all right? And I'll show you why that happens. And equals, okay? This is what that is, all right? That's the equals operator. It's the equals operator. Copy and CTOR, copy CTOR and the assignment operator aim to prevent alias. Now, I'll show you why. So, get our Microsoft Paint out here. All right, we've got Microsoft Paint. It's a good day. Let's do dark mode, shall we? Cool. All right, everybody. So we're gonna pretend like we have a very simple struct. Okay, we're gonna start with a very simple struct today. How big's our text? I don't know. Let's make it here. Now, a struct in a class can be the same thing, right? So we're not going to worry about the the difference between a struct and a class right now. We're just more concerned with actually having an object, right? Structs and classes both make objects. What's going on here? I messed it up. So let's say in here, I'm really messing this up today, guys. We got to give it a name, don't we? Struct person. And our person might have a string name. And they might have an int age, something like that. All right, that's our struct there. Yes, the alpha application. Yes, a struct and a class are the same thing, right? Hey, someone answer me that question. That will be on your test. What's the difference between a struct and a class? What's the only difference between a struct and a class? What is the only difference? You guys know that. So somewhere here in our code, we're going to pretend that we have a person P1 and we're going to have a person P2. And there's actually two ways that we can kind of do these things here. Let's see what we've answered. Classes are default private. Structs are public by default. Yes, very good. All right, very good. So let's talk about these things here. So let's say we have a person P1 and a person P2. Now we can call the copy constructor by doing this. Person P3, and then if we actually pass in a object. If we pass in an object of the same type, this calls the copy constructor. All right, we went over this last time. And then we can also call the assignment operator overload. All right, we can call the assignment operator overload. And that happens when we say P1 is equal to P2. All right, so this is where the assignment operator comes in. Essentially, these do the same thing. All right, and the thing is that it's going to take the object on the left-hand side here. You know, whether that might be this whether it might be this P3 here or this P1, it's going to overwrite the data with whatever's in the right-hand side, all right? So P3 should be a copy of P1. P1 should be a copy of P2. All right, so hopefully that makes a little bit of sense. Pig asks, can structs have functions? Yes. The only difference between a struct and a class is the private and public access. You can make, for every class you've ever made, you can make a struct. That's exactly the same, just by specifying the access members, all right? So, by default, the C++ compiler, when you type these things, see, we've defined this struct for us. Let's go ahead and add this to our notes, actually. Why do the memory issues ensue? First off, why do memory issues happen if we do not implement these three things? Well, C++ will automatically make some for us. All right, it will make the destructor, the detour, it will make the copy constructor automatically, and it will make the assignment operator automatically. Okay? C++ will make them automatically. And that's to, make our code work. Because honestly, whenever I type my code, I'm going to want to do this. I'm going to want to say, hey, P1 equals P2. And it would be annoying if I had to define the assignment operator every time. So C++ says, you know what, I'm going to do this for you automatically. But it doesn't always work. So in this case, it works, and I'll show you why. Let's pretend like we've got our objects. All right, this is going to be P1 here, and this will be P2. This will be our P1 object, and this will be our P2 object. Now, this is a very simple operation for C++. It's going to say, you know what? Let's say the name in here is, I don't know, JP. That's what friends call me. I'm your instructor, so don't call me JP, but I might have the name JP, and my age might be, I don't know, 25. Okay? And so all that has to happen here is say, hey, P1, you're going to take these values. You're going to copy them over exactly. So very easily can this Just happened. It says, you know what, you're going to get JP now, and you're going to get age 25. So, in some sense, this is a deep copy, right? A deep copy. We went over that last time, right? And a deep copy happens when each object has its own memory, and it's just going to copy the values inside of that object or inside of that variable. All right? So that's what happens with an assignment operator or a copy constructor by default. So now I'm going to show you the issue. It's time for the problem. Let's add something in here. What do you say? Add something in here. We're going to say, hey, you know what? You have a pointer. I don't know what this is. It's just going to be a pointer. All right? So let's say somewhere that got allocated and this becomes 00xa. What do you guys think happens? When I say down here, I say, hey, P1, you're now equal to P2. What kind of copy happens? What kind of copy happens? What happens here? You guys can answer this one. I just told you what happens with the other values, right? They're copied over. But what happens with the pointer? What do you think? An alias happens. Why does the alias happen? Well, it says you're just going to copy the values inside of this object. So you've officially made an alias. And that's what C++ does for you. Yeah, a shallow copy, right? That's exactly right. An alias, a shallow copy. That's what happens. C++ does this automatically for you. Isn't that so nice? C++ will automatically ruin your program by saying, I'm just going to make a shallow copy of this memory. All right, so now you've got an alias here, right? You've got two objects that are pointing to the same point in memory. And this is going to cause a whole bunch of problems. For example, let's say P2 goes out of scope and P2's destructor is called. Well, guess what? If P2's destructor is called, this gets crossed out, right? It's been returned to memory. But guess who's still using that? Guess who's still using it over here? P1 is still using that address because it made a shallow copy. And now it's a dangling pointer, all right? But we're not going to go that far. So does it make sense, just with this simple example, why we have to almost overload these things? When a class has a pointer inside of it, we have to overload these things. And the reason for that is because it's going to make shallow copies. All right? So please ask questions if you need to kind of understand that a little bit more. All right? But I'll kind of give you the example from class last time when we were working with this, right? It seems my programs are broken. All right. So what did we implement here, right? Well, we implemented our destructor. That's rule 1 of 3, right? That's rule of 3, and that's number 1. That's number 1 right there. So Uchu asked, this is only an issue when we have pointers in our structs or classes. Yes. Let's check our notes. When should I use this rule? Whenever a class, or if you want to use a struct. Whenever a class or struct contains a pointer. All right? All right, whenever class or struct contains a pointer, that's when we consider it. So Chef says to fix our copies constructor, we should use new. That's exactly right. And look what we did, right? So let's start with the destructor, right? I'm getting ahead of myself here. We have the destructor, right? Where's that destructor? Well, it's down here somewhere. You guys probably right-click, go to definition, but there, bam, found it. Here we're preventing our memory leak. All right, so the destructor did that for us. Now let's look at the copy constructor. So by default, this copy constructor, if we don't overload it, we're going to make a memory. We're going to make an alias. So Chef says we should use new. Yes, look, that's exactly what we did here, right? We said, hey, this string is now equal to some new memory. And then we have to go through and do a deep copy of it. Synthos says these paint presentations are top tier. And we got some upvotes. Thank you, guys. That makes me feel so good. Yeah, I hope that's helpful. I will upload this little image, right? Might take out a few things like that. But I will put in here. How about this? A little note that says, oops. Shallow copy. All right. So that's why we use the rule of 3. That's the only reason. And so when it comes to the test this Thursday, I will ask you a little bit of something about that. And I'm not going to ask you to, say, code a copy constructor, but I will ask you this. When should I use this rule? What 3 things are involved? And what am I aiming to prevent? Okay? So hopefully that's fair. Hopefully you understand that, and you can let me know if I need to go back to that. So now, today, let's see, Uchu says, how do we implement new using that paint example? Okay, that's a great, I like your thinking here. Let's do that. What do you say? Let's do that. Let us do that. That's a wonderful idea. You should ask more questions like that. All right, so we're going to get a folder going today. What is that going to be? Well, it looks like it's October, spooky season. All right, we're still doing pointers today. It's fine. All right, and this is just going to be our copy ctor.cpp. This will be a quick little example. All right. Here we go, folks. Boom, grab my favorite stuff. Let's go find my main. I know it exists somewhere. Where are you, main? Wow, there it is. I found that just to avoid typing 3 lines of code. Wow, that's amazing. All right. And we're good to go. So, as I said, we're going to have a struct, say person, struct person. All right, and we say, hey, this person has a name. Hey, this person has an age. And hey, for some reason, they've got a pointer. What does that mean? Rule of 3, all right? Rule of 3 there. So, yeah, here I am forcing this struct to be a class. So now we need to do some things, okay? Now we need to do some things. The first thing we need to do is take care of our rule of 3. So the first thing we need is a destructor. Now I'm just going to kind of throw these in here if you don't mind. I'm just going to kind of throw these in here. So what does this have to do? Well, this has to clean up this memory if it needs. Now let's assume this contains a single object, okay? Not an array. This contains a single object. So let me ask you, let's see if you've been paying attention. If it's only going to contain a single object, is this okay? Is that okay? If it only contains a single object? And of course, if you want to clean up, of course you don't ever have to do this, but if you want to, it's good. No, it's not okay, right? It contains a single object. This is not an array. So unfortunately, we have to do our checks. Think back to your assignment, right? That assignment you guys had so much fun with, right? That was your favorite assignment that you've ever done. If your pointer does not equal null pointer, delete it. Okay? And for some of you guys who coded that remove chair function, you found that your program had some problems if you didn't set it to null pointer, right? So, no. So, okay. Young, Top Wolf, and Chef, they all say it might be okay. And, you know, your code might compile, and it might work, but we're not going to say it's okay. I want you guys to remember there's a difference between a regular delete and a delete with brackets. So even if you could get your C++ code to compile, we're going to keep it like this. If our pointer contains a single object, we're going to do our check, and we're just going to delete the single object. So Cade says, why do we have to set it to null pointer after we delete it? That's to prevent a dangling pointer. Now, guys, this is a destructor, meaning that it's going to be called at the end of this person's life. And so this really is not required. But then you need to ask yourself, let's say you have this function somewhere that says void, I don't know, this is from exactly your assignment, remove chair. And in this function, you do the same thing. Now here, in this, say, remove chair function, this doesn't get called at the end of a person's life, okay? I could say person P, and I could say P.remove chair, and then somewhere down here I could say cout, you know, I don't know, I could call some other function, right? I can say void foo. Meaning that delete was called in here, was called here. But person object is still alive. So somewhere down here, this function could use that pointer. All right, that function might be using the pointer. Right, so then in this function, void foo, I don't know, it's going to say, hey, if pointer does not equal null pointer, then you'll say, hey, cout, I don't know, the dereferenced version of that pointer. Now, what did I just do here? What do you think Valgrind would call this? So assume this was the sequence of events. Here we call delete, and then this foo function is going to check. So the first thing it says here is pointer not equal to null pointer. Pig says, what is foo? It's just like, it's a dummy name. It's just, yeah, it's just an example. So, yeah, so Cade's getting it here, but I do want to kind of make sure it sinks in for everybody. Notice we didn't set it to null pointer here, so it's going to check it. It's going to say, hey, this contains a value. And then it will dereference it, and this results in an invalid read. So many of you had that issue in your assignment with the remove chair function. You say, what the heck? My grid is printing this address. I don't know what's going on. And it's because you didn't do this. So you need to override it. So then this here, it won't get executed. So Cade says, we would need in everything that it's not the destructor, meaning we would need to set this equal to null pointer in everything that's not the destructor. Or say, is your program ending right away? If the program is ending, you don't have to overwrite it. All right, but if your program's not ending, that pointer might still be used. You should definitely overwrite it. All my homies hate remove chair. All right, so that's number one of rule 3, the rule of 3. Number 2 is the copy constructor, all right? Copy constructor always looks like this. It's going to be the class name, which then takes a constant by reference class name copy. It always looks like this. 100% all the time, it will always look like this. You just have to fill in the stuff here. So what are we working with today? We're working with a person. So what does that mean? It takes a person. 100% all the time, it looks like that. So that's number 2. Now, in this copy constructor, there's a few default things we could do. We could say, hey, we can say, you know what, this name is equal to the copy name. Absolutely. That's what C++ does by default. All right. If we don't overload this copy constructor, C++ will do this by default. Right? And this is okay. It will also do this by default. It will say this age is equal to the copy.age, right? And then it says, oh, you want me to do this, right? You want to say, hey, this pointer is equal to the copy pointer, right? C++ will do this, will do this. This is what C++ does automatically. That's the code it generates. Syntho says, when having a pointer in a class or struct, do we need to have all parts of the rule of 3? I would say yes. Unless you can guarantee nowhere in your program are the copy constructor and the assignment operator called. If you can guarantee that, then you don't have to. But what if someone reuses your code and they say, hey, you know what? Why is it mad at me? Stop it. No default constructor. Okay. Whatever. There you go. So let's say I have two people here, right? What if someone copies your code and just puts that class in there? And then somewhere down here they go, hey, P equals P2. Hey, person P3 is an exact copy of P2. Now, for those of you, I don't want to confuse you. This is actually the exact same thing if I say this, just because they're being instantiated here. So this actually calls the copy constructor too. I'll put these in some notes. This is the assignment operator. This calls the copy CTOR, and this calls the copy CTOR too. I know it doesn't look like that, but it does that. All right. Yeah, so Pig asks, what is the const person copy? That's just the other person in this case. That's just the name of the variable. And it has to be this way because you're not going to make a change to them. The reason it's constant is because you're not allowed to edit that other person, all right? You're not allowed to do that. And so since it's coming in as a constant, we can also pass it by reference because we're not going to make any edits to it. So that's just what that is. It's just a placeholder, as you might say. All right. So, Synthos, back to your original question. If you can confirm that these lines of code are never typed anywhere in your program, you don't have to implement it, but I would strongly recommend it. Where we are now in this class, we're not going to go over the assignment operator just yet. So it's not like I'm going to require you to go back through all your codes and like implement it. Obviously in your, assignment 4, I didn't make you do these things, right? And that's because for the most part, if you did it the way I wanted you to, instead of say, standing, you like took the person out of the space and stood them in the next space, instead of just like swapping the spaces, you would have avoided the aliasing, the shallow copies there. So, yeah. So hopefully that answers that question. Pig says, is there a benefit to passing by reference instead of passing by value? Yeah, it's faster. Because so tell me this. What happens when, you guys should know the answer to this. What happens if I do this? Let's say it gets called down here. What happens right here? This is not passed by reference. Something happens. What happens? What happens if this is passed by value? What's the thing that happens? You can be as general or specific as you want, but you guys should have some idea here. What happens when this is passed by value? As soon as I call this, we're passing in object P2 here, and then something happens. It makes a copy, right? What happens here? The copy constructor gets called. The copy constructor gets called. Yeah, it's a new object, right? This is passed by value. So a new object is initialized. How is it done? With the copy constructor. Basically, that says you're going to pass in some new object here that takes P2 as a copy. All right, that's what happens there. You're exactly right. It makes a copy. So if we do it this way, if we do pass by reference, this whole copy constructor thing is skipped. The object's just passed right through. It's like a chute. It's like a slide, you know. It goes right to the program. No copy constructor gets called. So it's faster. Now, this part here, obviously, if I wanted to, it's by reference. So I could be like copy.name equals whoops, right? I changed their name by accident. So by putting the const up here, we're preventing this from happening, right? You'll see the little red pops up there. Right, exactly, Chef, right. So we're gonna have to make it constant. And that's why we do that. Why is it passed by reference? Well, because it's faster. And also because it's constant, right? There's no point in making a copy if we're not going to mess with it, right? There's no point. Like here, you could do this, but what's the point? Like, look, it's even mad at you. I think this is for other reasons, but what's the point of this? If you're going to make a copy and then make it constant, why? Kind of why did you do that? This copy up here is only going to live for as long as this function call lives. So there's really no point to making it constant. But if we're going to pass it by reference, we're going to say, hey, don't make a change to this, please. I want this to remain as it was. Yeah, cool. So I'm glad we could get through that. And now here, by default, this is where the shallow copy happens, right? This is where the shallow copy. And so we need to say, hey, C++, stop, right? Stop. We're going to be the crossing guard. We're going to say, stop. Do not do this. I actually need you to do this, buddy. I need you to make a deep copy instead. Halt. New int. And then we say, hey, pointer dereferenced is equal to the copy pointer. I'm having a bad day here. Dereferenced. And we fixed it. It's been fixed. Corrected. All right? It's been corrected. It's been corrected. Does that make sense? Does it make sense what I did there? Now we're going to kind of do the assignment operator a little bit. Just a little bit. Now, here's what it looks like. This is what it looks like. I just want you to see it. Let's see. Oh, I get deep copy for shallow. Exactly, exactly. You are welcome, Muchu. So this is what the assignment operator looks like. Kind of looks like a function, right? But instead, in string, we're going to use an overwrite. This looks a little bit more. Your speed, right? So we're going to pretend that this is our assignment operator. So instead, here we're going to do. Hey, this is just going to be called overwrite. All right. We're going to make this an overwrite. And we'll get back to the operators later. Now, what's the difference between these two things? Can someone tell? This is very important to understand. What is the difference? Like, when does this happen and when does this happen? What's the difference? There's two objects involved here. You're always going to have, say, a P1 and a P2. And in here, you're going to have a P1 and a P2. But what is the difference between a copy constructor and an overwrite? They're almost the same thing, except there's one very important aspect that you need to consider. So, say, and the main thing is, this is a function, and this is a constructor. So, let me kind of clean it up, right? Yeah, so, Cade was ahead of me there, right? One's a constructor and one's a function. So, here's my question to you. In the constructor, are both objects already alive? So, Chef, yes, Chef's, you're getting it here, right? It can be called on an object that is already created. So in the constructor, are both objects already alive? Are both of them already alive? If not, you know, which one is, which one isn't? Kind of what's the thing here? Let's pretend like we've got person P2 taking in P1. So who's already alive and who's just being born? Can you answer that question? With this code, who's being born and who's already alive? Yes, Chef, right? Only one of them is. The copy, right? And who's the copy? It's P1, right? Am I being confusing? Who's alive? Who's dead? Tell me. Okay, so P1. So stop me if you need me to slow down here, right? But in terms of the copy constructor, P1 is the one who's alive, right? And P2 is born. P2 is brand new, right? Pig, you got it. So P2's being born. P1 is alive. So this pointer here, this is essentially, let's see who's being born. This is essentially P2's pointer. Does it matter what is in the pointer at this point? That's my question. Does it matter what's in here? Does it matter what is in here? P2 is just being born, by the way. right? So does it matter what's in that pointer? Or can we make some assumption about it? And the assumption is, does this already contain an address? Like, does it already contain allocated memory? At the time that say, hey, this person's born, does their pointer already contain memory? No, it doesn't, right? Chef's right. So it doesn't matter. You know, we're kind of just winging it here, right? We're kind of just winging it. Actually, we did make a huge mistake. It does matter what's in this one, right? It does matter. So I do got to check this. I'm sorry, guys. I got way too ahead of myself here. I do have to check this one. Whoops. I do have to check that one. But as for this object, we don't have to worry about it, right? It doesn't matter what's in this here. It does matter what's in the already alive one, but this one, it doesn't matter. All right? Doesn't matter. Maybe I'll do an else here. We'll say, hey, you instead equal null pointer. All right. So sorry about that. Obviously, I'm dereferencing this one. Before I dereference it, I want to make sure that it's not null pointer. So I'm sorry that I made that mistake, but I don't think it's too confusing for you guys. All right, so now we come down here, right? Are both objects already alive? So Yang asked, does it matter for the alive one, but doesn't matter for the new? Yeah, exactly. Yang, you nailed the nail on the head there. You hammered the nail on the head. I said that completely wrong. For the one that's already alive, you need to be careful. You need to be aware that that object may have seen some things, right? Maybe it went to war. Maybe it was just born. Maybe, you know, it's done a little bit too much math. Whatever. Its pointer may contain something, or its pointer might not contain something. And so for the one that's already alive, we have to consider it, right? We have to consider what exists. But for the brand new one, it doesn't matter. This, whatever, I'll overwrite it. There's obviously nothing in there. This person is brand new. They're seeing the light of day. So now it's time for the overwrite here, right? In this case, both P1 and P2 are already alive. Both P1 and P2 are already alive. Patty's coming to say hi here, so if she gets close enough, I'll show her. But let's stay on subject here, all right? P1 and P2 are already alive. So the first thing that happens is this. This is okay. We're allowed to do this because they're not pointers, right? This already makes a deep copy by default, all right? But now this is not, this kind of copy paste here, it doesn't work. We have to check a few things. All right, I'm going to kick you out, but first you're going to say hi to everybody. Yeah, you're going to wish them luck on their test on Thursday. Yep, hi Patty. You got to look them in the camera here. There you go. She's pretty upset. Get out of here. So, yeah, sorry, I do get distracted easily. Chef says we need to be careful with both of them. Yes, that's correct. We do need to be careful with both of them. So the first thing we should check is if, say, this pointer does not equal null pointer. If this pointer does not equal null pointer, what does that mean? That means that this object has already been alive, all right? It means that this object has already seen some stuff, right? So if it's not, let's say, hey, you are gone now. And let's overwrite it, all right? So this is us being careful with P2, all right? This is us being careful. So we're going to say this object is already alive. Thus, we need to deallocate the old pointer. Okay? Thus, we need to deallocate the old pointer. Once we've done that, we can then move on to this part. Once we've done that, we can then move on to this part. All right? So does that make sense? And now we don't need this else bit because I handled it up here. Does that make sense? For whoever who asked me to do that originally, which was a great idea, we basically just took this example and coded it. Does it make sense? Pig says this avoids an alias. Yes, exactly. This avoids an alias, right? Because by default, the compiler will make a shallow copy of the pointer. By default, the compiler does this. The compiler will make this line of code. And so we have to prevent that. We have to force a deep copy. And down here, right, after I delete it, I am avoiding the dangling pointer. Because the pointer, it looks like it's getting used down here somewhere. So, you know, I've got some pretty safe logic here, but I'm still avoiding it. Yep. Avoids an alias. So the copy is meant to overwrite this. Yeah, well, yeah, so I would say, in this case, right, what happens here, you say something like P1 equals P2. So P2 happens to be the copy. So it looks like this, rather. This is equal to P2. Or rather, if you really wanted to, you could say something like this. Dot overwrite. I'm really struggling here. This overwrite with the copy. That's kind of what happens here. So whatever's on the left side here, which is P1 or this, its name is going to become whatever's on the right-hand side, the copy. Its age is going to become the copy's age. Its pointer, whatever's inside of it, is going to become a copy of whatever's inside of the copy pointer. We have to make a deep copy, though, not a shallow copy. So, Chef, does that clear things up? Anybody else? Do I need to spend some more time on this? For the remainder of class today, I'm actually going to do this override function for our string class. All of this stuff, by the way, for those who are maybe a little worried, anything I coded today will not be on the test. Anything here I put in the notes, though, this stuff will be. So, just so you know, if you're like frantically writing code right now, don't worry. I won't ask you to code this stuff on Thursday. I'm only going to ask you the basic questions. Cool. Chef, awesome. Thanks for letting me know. And Uchu, you are welcome. All right. So, I'll go ahead and put that stuff up on Web Campus today. Test is on Thursday. So now we're going to continue on just with our string class. We only have one more thing to write. I'm also going to briefly go over this delete at function, which is what I crammed. And with whatever remaining time I have, I'm going to show you how to make a multi-dimensional array. Now, by that time, your brain might be a little fried, but at least you'll have it on the YouTube video for when assignment 5 comes up after the test, okay? So at least you'll have the reference for that, and you can come back and watch the video for the multi-dimensional part if you need. So if you remember from last class, this here, let me just do this. Whoops. This is a CS202 string class, which is basically, right, it's just a dynamic character array. It's just a character array. That's what a string is. Okay? So you can see that this class contains a pointer, and it has a length, right? And we did a whole bunch of stuff here. We made some special constructors, right? Our parameter constructors. We made a default constructor, and then we kind of did some rule of 3 stuff. So this is RO3 number 2, right? That's the copy constructor. The destructor is RO3 number 1. Looks like they're a little bit out of order. Doesn't matter as long as they exist. And now we're going to do the assignment operator overload, right? Now, we haven't done that one yet. So down here, we've got this is RO3 number 3. All right, this is basically the assignment operator equals, right? Now, we're going to go over this just very briefly, but I am going to review this delete at function, all right? Because I crammed it last time. So if you remember, I'm just going to kind of walk through this with you. We did a concatenate. You guys can reference that if you need. Now we're going to do a delete at, right? We're going to do a delete at. So we're basically going to turn... Patty does demand an audience. She's sitting here right now watching us. We've got Patty here, and we wanted to say, you know what? I want you to only have one T in your name. So we would call maybe a delete at. And we're going to put that, say, int I. What index do we care about? Probably that's 0, that's 1, that's 2. So either 2 or 3. So we'll call delete at, say, index 2. And we're going to end up with PATY. Okay? So that's what this function does. Right? I already had it here. My brain works the same way, I guess. All right? So what we're going to do with that is we're not just going to take the character out of the array. We're going to make a whole new array. Because I want, say, my array to always have the size that it needs. This function is memory efficient. It's memory efficient, meaning that the object will only contain as much memory as it ever needs. It will never have more memory than it needs. Usually, if it's memory efficient, it's slow. All right. Why is it slow? Well, every time I call delete at, I'm going to the operating system. I'm requesting new memory. I'm making deep copies. That's what's slow about it. There are faster ways that you can optimize your code. But for the purpose of this class, we are doing the memory efficient way. So to do that, we're going to need to allocate an array of length -1. So basically, we're going to go from size 5 to size 4. Right? That's what this part does. So you guys should have been able to follow that last time, right? This is step 1 right here. Let's kind of put them all up here. All right? And then the next part, this one, someone said, I'm going to need to review this, right? I think it was Giovanni who said that, which I don't blame you, right? We've got this first half, second half stuff. So I'm going to show you what I'm doing. So basically, I do it this way. I say, hey, we're going to say we've got PATY here. And we're going to put, say, the indexes in there just for fun. So the index here exists at 0, 1, 2, 3, 4. All right. And now I need to copy it into an array that's smaller. We've got 1, we've got 2, we've got 3, we've got 4. And we need to ignore one of those indexes, right? And it happens to be the index that we care about, which will be, if we're deleting at 2, we don't want to worry about this one. So the first for loop's pretty easy. It just says for j is equal to 0. Now, I named it int I up here, okay? I named it int I. Probably I should preferably name this index so that this for loop doesn't look so ridiculously hard. All right. So for j is less than our index, the new array at j is equal to the original array at j. So Chef says, would it be possible to do it with one for loop, like with j less than length 1 in an if statement? Yes. I'll do that for you. I'll do that for you. You know what? Let's scrap this one. Let's scrap it. So the first part we need to worry about, let's do the whole thing. What do you say? So Chef says, like with j is less than length -1. All right, let's do that. Let's say, hey, whatever our length was -1. So what does that evaluate as? This is going to be roughly 4, right? This is going to go from 0 to 3. So for the first bit, let's say if j is less than the index, that we care about, then we can go ahead and put it in there. So let's check that. What do you say? So up here, let's start at j is equal to 0. J is less than length minus 1. So first we'll check to see if 0 is less than 2. Is that correct? Yeah. 0 is less than 2. So we're going to copy P right into this spot here. Then we'll go up to 1. Is 1 less than 2? Yes, it is. So we're going to copy A right into this spot. Now we're going to go up here to 2. Is 2 less than 2? No, it's false. It's false. And in fact, do we even want to do anything with that? If it equals 2, we don't want to do anything. We don't want to do anything. We're going to skip this guy. Say nothing to do. So then we're going to need another if statement. Actually going to go... We'll do the easy way. So we'll do an else if. What is this condition? All right. We've already handled this part, right? P and A. We're skipping this. So we shouldn't have a condition for this. We could if we wanted to, but we're not. What's the other condition? What are we checking for? We checked if j is less than the index. We'll know if j is equal to the index because we're going to skip it. So Pig says, could you just do if j does not equal index? Yes, but you have to be careful. You have to be careful with that because, as Synthos says, there's a first half and a second half. There's a first half and a second half. And I'll show that to you right now because people are getting it, right? So if j is greater than the index, right? If j is greater than I, whatever you call it here, what do I put in here? What's the thing? What do I put in here? What do I put in here? So we skipped 2. We skipped 2. So now we're at 3. Now we're at 3. So what code goes in there? It doesn't look like this. It doesn't look like this. This does not work. Why does that not work? I'll show you. We've got a j minus 1, all right? What does the j minus 1 go on? Okay, so you guys are having some great ideas here. So Pig says j minus 1. Where does that go? That's my question to you. Yang says new array at j is equal to string j plus 1. Let's see if that works. So now we're at, we skipped 2, so now we're at 3, right? So I said, hey, new array at 3 is equal to the old array at 4. So, yeah, we get the y. So, Yang, you're partially correct. But then what happens here? We missed it. We missed it. And in fact, I think that'll be enough. We missed it, though. We missed it. So, Pig is right? We're going to want to make this new array j minus 1. And we're actually going to want to keep it equal to the string at j. And so that will happen to be at j is equal to 3. We're going to say that the new array at 2, or 3 minus 1, is equal to the array at 3. So the t gets here. But now this for loop is going to exit. So we actually need to take off this minus 1 here. There's a whole bunch of ways to implement it. Okay, so Chef, Yang, Pig, you guys, your heads are all over the place, just like mine is, right? Just like mine is. So you could do this in 10 different ways. I promise you. You could do it with 2 for loops. You could do the plus 1. You could do the minus 1. It all depends on how you do it. But it looks like this one is what's going to get it done. It looks like this one is what's going to get it done here. So, Pig, I'm glad that you see that. Uchu says, interesting because the 2 can't just be blank, right? Yep, that's what happens here. The 2 can't just be blank, so the j minus 1 will shift it over 1. Okay, and it will end up dragging this t into that t, and it will drag this y into that y. Does it make sense? So last class I did it with 2 for loops. I did it with 2 for loops. In this one, we changed it up a little bit. We've just got some if statements in here. And we're going to skip over that index. So hopefully that makes sense. And then down here, what do we call? We got to delete the, what are we deleting here? We're deleting the old one, okay? So this is the old array. We don't need it anymore. This array contains Patty. This is the Patty array. We don't want it anymore, so we send it back. And then it looks like we make an alias here, right? But we kind of don't, because we already deleted the old one. So now the old array contains the address of the new one. And then here I prevent the new array from being an alias. And then I subtract the length. And by the time we get down here, we are officially at Patty with 1 T. We've officially made it to Patty. Does it make sense? Now I'm going to add a little bit of a safety thing up here just because I forgot to last time. If index is greater than or equal to 0, and if our index is less than the, did I call it length? I think so. Then we'll do all this code. But if index is less than 0 or the index is greater than or equal to the length, sorry, I'm doing logic in my head. We'll just return. That's better. Okay. So this code will go up. If you need some more time on this, let me know. We've only got 10 minutes left here. Oh gosh. So we're going to do the overwrite. All right. I'm going to kind of speed run this one. Well, we'll see. We'll get to what we get to, and I won't worry about rushing things. Rushing things is when people miss things. So I won't rush this one. This is the assignment operator overload, right? This is the assignment operator overload. This is what that is. All right, this is the assignment operator. So what do we need to do? Well, guess what? Both objects are still alive, right? Both objects are alive. So we need to be careful about both things. The first thing we should consider is the original object, right? We've got this and we've got copy. We've got this and we've got the copy. Hi, Patty. We've got this and we've got the copy. So the first thing we need to consider is we're overriding this object, right? So whatever was in here needs to go. So this is the same as saying Patty is equal to loaf. Notice that Patty, this array, it's a different length than this array. So we need to send Patty back to the operating system, and we need to make a new array for loaf. Okay? So that's what we're going to do here. So the first thing we need to do is delete the old array. So we're going to call delete this string. Okay? We're going to delete the old array. This deletes Patty. All right, Patty's now going to the operating system. Now we need some new stuff, right? So now we're going to say copy, I don't know, the length of that object. This length is equal to the copy.length. And then tell me, what did I just do here? Is this okay? Is this okay? Or is it not? I'll wait for an answer to move on to Chef's question there. But is this okay? Is that enough? Not okay. Syntho says it's not okay, right? That's a shallow copy. We did a shallow copy. That's an alias. No, that's not okay. Chef says, should there be a check to see if it's not null pointer? Yeah, you could do that. But do you remember from last class that if it's an array, delete will assume that this could be an array of size 0. An array of size 0 is null pointer. So hopefully, Chef, that answers your question. If it's a delete with brackets, meaning it's an array, if it's null pointer, the program will not break. It will say, this is just an array of size 0. No problem. So let me know if that's confusing to you. I did put that in the notes, pretty sure. So now we need to do a deep copy, all right? So the deep copy happens like this. Step 1, allocate. This string is equal to new character length, all right? Step 1, allocate. Step 2, deep copy. Well, I should say this is probably step 1 up here. This is probably step 2, and then this is probably step 3. Is Patty back there? She really doesn't want you guys to learn today. I'm sorry about that. Now we got to do the deep copy. Now, deep copy happens by a for loop, unfortunately. You can't just dereference it. That won't work. So for I is equal to 0, I is less than this dot length. I plus plus. And we're going to say this string located at I is equal to the copy.string located at I. Okay? So that's our override function. Very easy. Now there's probably one thing I want to do here. I probably want to set this to null pointer. Okay? Because what if the array on the other side happens to be empty, just like this? That means that the string will be null pointer. And in fact, this length will be 0. So this for loop will never execute. All right? Cinto says if it wasn't an array, we wouldn't need a for loop. That's correct. Here's the example of that from the person example, right? In the overwrite, we deemed that this pointer only contains a single object, so the deep copy happens here. Similarly, from that override example, this is step 1, deallocate. This here is step 2, allocate. And this is step 3, deep copy. Notice that we don't need the for loop. Why? Because it's just a single object. It's just one thing. Over here, we do the same thing. Step 1, deallocate. Step 2, allocate. Step 3, deep copy. But guess what? This is a whole array. So we need to go through element by element and make a deep copy of it. So let's give this a try. What do you say? Let's say S4 dot print string S4 dot overwrite with new string S4 dot print string. All right. So we're kind of at the end of class here. We've got 3 minutes, but I'm just going to run the code. If you guys got any questions, now's the time. We didn't get to the multi-dimensional arrays yet. I'm not sure what I'll do with that. I'll look at the assignment. We'll see if we'll just get to it next time. So don't worry about it, all right? I will do the worrying. You don't have to. As for the test, you know, that's coming up. Make sure you study. You can use that whole sheet, all right? You can use that whole sheet. I just saved this, right? Mail, I'll get to that in a second. CS202 student, you can submit them as much as you want, pretty sure. If you can't, let me know. But I'm pretty sure you have unlimited submissions. So go back and fix things if you want to. Yeah, did the stream, I think the stream worked well today, didn't it? All right, everything compiled. Let's see if we run it. Okay. So what happened here? Whoop. Don't you... There will be no DDoSing, okay? Class is over. So what happened, guys? Let's look just real quick. I don't know if you can see it. My face. So what did we do? This was Patty Loaf, right? This was Patty Loaf. That's what we see here. And then we deleted number 5, so the L came out. All right. Then we printed again. That's Patty Oaf. And then here's S4, which was S. And then I overwrote it with Patty Oaf. All right. And if I Valgrind it, we should have no memory problems. Okay. CS202 student, I'll fix that right now. Okay, I'll fix that right now. Chef, I'll fix that. Sorry about that. I'll make sure you can resubmit it. That was class today. All right. I hope it made sense. I hope you learned something. Mail asked, anything you should know before the test? Have your notes ready. Like I said, you're using lockdown browsers, so write them down, print them out, whatever. And just do everything you can before you start digging through your notes, okay? Don't sit there and dig through your notes for every answer. Go through your notes only when you have to. Try to get everything done that you can. All right? You're free to go. Thanks for coming today. Chef, you're welcome. CS202 student, you're welcome. Uchu, you are welcome. Fuzzy, you are welcome. Have a great day. Swallowed an ice cube. Kane, you're welcome. Top Wolf, you're welcome. Waffle, you are welcome. Yang, you're welcome. Pig, you're welcome. I'm gonna hydrate. I'm sorry. I have to. Synthos, you're welcome. Giovanni, you are welcome. Oyman, you are welcome. Hammer, you're welcome. Turbo, you are welcome. Have a great day, guys. I'll see you next time.